Hello students, we're going to continue our discussion on powers of 10, but I'm going to take it in a different, more broader context, and we're going to talk about it in the context of what I refer to as technical notation. So technical notation is a way that we can talk about numbers, and we can use the same number and describe it in 4 different ways. And it's the same idea that if I were to come to you and see you in the morning, I could say good morning. Could say guten tag. I could say konnichiwa. I could say nihai ma. So I could introduce myself in several different languages. And that's the idea with these numbers, is that we're going to express the same number in several different formats or several different languages, if you will. So technical notation is a term that's used to describe a system that can express a number 4 different ways. And those 4 different ways that we express these numbers are going to be the decimal form, the scientific notation form, the engineering notation form, and a metric prefix. So in the decimal form, we're simply talking about a number as it is written. So it could be 100, it could be 0.00135, but it's a number that we're used to dealing with in grade school before we enter to some basic forms of algebra and that type of thing. So it's just a number that we learn how to multiply, divide, add, and subtract with. So just the basic raw decimal form. Another way that we can talk about numbers are scientific notation. And scientific notation is a number that is written between 1 and 10. It's larger than 1 and less than 10, and it's raised to some power of 10. So the dichotomy of this is that I would have a coefficient, which we talked previously in the power of 10 video, just the number. It could be 1, it could be 3.42, it could be 7, it could be whatever we choose. The base number, which is going to be 10, because we are talking about terms in power of 10, and the exponent. In other words, what power is this 10 raised to? So this would be the 6th power. Engineering notation is a number that is written whose base is a multiple of 3. So 10 to the 3, 10 to the 6, 10 to the 9, or 10 to the minus 3, 10 to the minus 6, 10 to the minus 9. Some multiple of 3 is what that exponent will be when we're discussing the engineering notation. I do have some examples here at the bottom. Let's see if we can get to that. And so basically what we see here is this 314,159 would be written as 3.14.159 times 10 to the third. Number smaller than 1, 0.0137. We'd write this number, move the decimal point to 3 spaces, and then that becomes minus 3. So we'll get some more practice in that. And then the final thing I want to talk about when we're talking about technical notation is we do use a method called metric prefix, and it is, to a certain extent, it is a shorthand, if you will. And these are numbers whose exponents are multiples of 3. And we've taken those multiple of 3 exponents and replaced it with a symbol. And that symbol represents something. So if I look at a metric prefix, we have these numbers. There's 10 to the 1. Remember, this is our base number 1, and we're going to talk about numbers larger than 1 and numbers smaller than 1. And as I move in multiples of 3, 10 to the 3, 10 to the 6, 10 to the 9, 10 to the 12, that becomes 10 to the 3 is a kilo, 10 to the 6 is a mega, 10 to the 9 is a gig or a giga, and 10 to the 12 is a tera. Likewise, when we go to numbers smaller than 1, 10 to the minus 3 is a milli, 10 to the minus 6 is a micro, and this is this funny Greek letter called a mu. It looks like a U with a tail in front, so that's a Greek letter. 10 to the minus 9 is a nano, and 10 to the minus 12 is a pico. So basically what we're looking at in these examples here is we take this power of 10, 1.47 times 10 to the third, and we simply take this times 10 and whatever power that is and replace it with a symbol. The symbol is K. 10.467, 10 to the minus 3. We replace that 10 to the minus 3 with a milli. 47 times 10 to the 6th is a mega, 47 meg. And then so we just go down this list. So we're looking at kilos, mega, micro, giga, nano, pico, and tera. So all these letters designate for numbers that are really big or really small. And this is an easier way to recognize this. You can simply use this number if you understand how the symbols work, and it'd be easier to multiply by 1.47 than it would be to 1.47 times 10 to the third. So when we deal with really small numbers, really large numbers, this is a recommended way of using that. So we'll continue our discussion on every single one of these numbers and do some exercises.